The fourth class of electrochemistry. So, last class what have we discussed? We have discussed about the standard hydrogen electrode, and that hydrogen electrode was used to calculate or to measure the standard electrode potential of any electrode. So, today we will discuss how the electrode potential of an electrode is determined by using the SHE, and then we will switch over to the electrochemical series. So, this is a series known as the electrochemical series, in which the elements are arranged in either the increasing order or decreasing order of their standard reduction potential. So, before going to this series, let us discuss how to determine the standard electrode potential of an electrode. So, last class we have discussed what is SHE and how it's. Today we will discuss more about this, then we will switch over to the series, electrochemical series. So, let this, suppose we want to determine the standard electrode potential of zinc electrode. So, what we will do? So, first we need the standard hydrogen electrode. Already we have discussed its construction, its working, its cell reaction, its representations, its demerits, its merits in the last class. So, this is our standard hydrogen electrode, in which the standard conditions are made. Which are the standard conditions? Now, the HCl solution. Here we have taken the HCl solution whose concentration is 1 molar. Then we have dipped a platinum electrode, the platinum where which there is a platinum plate coated with platinum black, and we pass our hydrogen gas at 1 atmospheric pressure. Okay. Then this temperature of this setup is maintained at 25 degrees centigrade. You know the standard conditions, temperature should be 298 Kelvin or 25 degrees centigrade, concentration should be 1 molar concentration, and the pressure, if it is a gas electrode, the pressure should be 1 atmosphere. So, it is about the standard hydrogen electrode SHE. Then we want to determine the electrode potential of zinc electrode. That is why we have to combine this with the zinc electrode. I have taken the zinc electrode in the right hand side. You can take it either in left hand side or in right hand side, because we do not know whether it will act as anode or it will act as cathode. So, that is why this is the zinc electrode, in which the zinc rod, this is the zinc rod which is dipped in zinc sulphate solution. You know it, zinc sulphate solution whose concentration is also 1 molar. Then externally these two, the SHE and the zinc half, they are connected by means of a wire, and here this is the voltmeter through which we can read the E cell, the EMF of the cell can be measured by using this. Then internally they are connected by means of salt bridge. Already we have discussed in our second class what is the salt bridge. So now it is the combination of SHE and the electrode whose electrode potential is to be determined. Okay, and here we have to determine the electrode potential of zinc. The conditions are maintained under standard conditions. So what will you obtain? So from this setup you can find that the electrons are flowing from which direction to which direction? They are flowing from zinc to the SHE, standard hydrogen electrode. So, it can be known from the deflection of the voltmeter. Voltmeter deflection nu तुम जानी परिबो इलेक्ट्रॉन टा कोठु कोठ की फ्लो करछि, either from SHE to zinc or from zinc to SHE, and from this we obtain that the electrons are flowing from the zinc electrode to the standard hydrogen electrode. So, what will you think about this? So, माने कौन एट में पाइबो the zinc electrode electrons सुधा flow करछन्ते towards SHE. That is, zinc is undergoing what? Oxidation or reduction? Obviously, it will undergo oxidation, because you know oxidation is the loss of electron. So, that means here zinc undergoes oxidation producing electrons. So, this is your oxidation. This is the oxidation half reaction, and this cell now becomes your anode. So, you know red cat and oxidation takes place at the electrode known as anode. Here zinc becomes your anode. Then what about the standard hydrogen electrode? That will act as cathode. That means H2, 2H plus. So it will undergo reduction. 2H plus, by gaining electron it will produce H2. So this is your reduction reaction. Okay. So when you combine these two, you will obtain the total cell reaction of this setup. Okay. 2 electrons cancel out and you will obtain the cell reaction like this. This is the cell reaction for this setup. Okay. Then from the voltmeter, you will obtain a certain value of the voltage, that is you will obtain the reading, that is E naught cell is found to be 0.76 volt. Okay. So E naught cell, that is equal to, you know, it is the oxidation potential of the anode, the oxidation potential of what? Anode. That is why I have written Zn2 plus. From this presentation, what do you confirm? Here oxidation place. This is the oxidation potential plus the reduction potential of cathode. So the reduction potential, either you write down H plus half H2 standard. So E naught cell equal to, that is equal to 0.76 volt, and the reduction potential, you know, last class we have discussed the standard oxidation potential as well as the standard reduction potential of standard hydrogen electrode is arbitrarily fixed at 0. That means this value becomes 0. So what will you obtain? E naught Zn2 plus is equal to 0.76 volt. So this is what? This is the standard oxidation potential. As we have represented, zinc is converted to zinc Zn2 plus. So this is the standard oxidation potential. And dear students, according to IUPAC convention, the electrode potential are represented in terms of the reduction potential. So what will be, if this will be the standard oxidation potential, what will be the standard reduction potential? It will be equal in magnitude but opposite in size. That means the E naught Zn2 plus Zn will be equal to how much? Minus 0.76 volt. So this is the standard reduction potential. Standard reduction potential of zinc is found to be minus 0.76 volt. Okay. So like this, if you want to calculate the electrode potential of any electrode, then combine it with the SHE, then you obtain a value in the voltmeter, that is the E naught cell, that is the cell potential, and from that value you can calculate the standard reduction potential of any electrode. Okay. So by using this, you can calculate so many the electrode potential of so many electrodes. So after obtaining the values, they are arranged in the form of a series. Ebre samaste karo tume janiga standard reduction potential. Then we will arrange them either in the increasing order or in the decreasing order of the standard reduction potential. So you will obtain a series that is known as the electrochemical series. So what is that? How to define the electrochemical series? The ECS, electrochemical series. This is nothing but the arrangement of various elements in order of increasing standard reduction potentials. Okay. So either you can write down increasing order or you may write down the decreasing order of their standard reduction potentials. But I have taken this to avoid the confusion. So increasing order of standard reduction potential. It is also called as activity series. In the school level, you must have heard this term activity series So, this is nothing but your electrochemical series. Okay, let us discuss more about the electrochemical series. So, the electrochemical series look like this. In this series, the elements are there in the left hand side, then the electrode reactions are written, then their standard electrode potential. You know, standard electrode potential means their standard reduction potential. These values are written in the increasing order. So, that means the minimum value lies at the top and the maximum value lies at the bottom of this series. That means what do you see from this? So, here the elements are arranged like lithium, potassium, calcium, barium, sodium, magnesium, like this. Then your hydrogen is placed at the middle, then copper, silver, gold, like this. Finally, the fluorine is placed at the bottom of this series. So, here then the electrode reaction. What is that reaction? As we are considering the standard reduction potential, then we have to write down the reduction reaction. So, here the what will be the electrode reaction? Li plus electron gives us Li, potassium K plus electron gives rise to potassium. Similarly, magnesium plus by gaining electron is converted into magnesium, like this. Then for hydrogen, what will you obtain? What will be the reduction half reaction? What will be that? That will be 2H plus 2 electron gives rise to H2, this like this like this. Then F2 plus 2 electron gives rise to 2F minus. These are the electrode reaction. Then at the right hand side their values are given. Just like for lithium, the reduction potential, the standard reduction potential is minus 3.045 volt. Then for hydrogen it will become 0.0, you know. Then for fluorine its value is maximum, that is 2.87 volt. Okay. So, what do you observe from this? Here the electrode potential, the reduction potential, the standard reduction potential value goes on increasing. Negative value, negative, 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 then 0, then positive, 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 maximum. So, this is the minimum value of lithium and this is the maximum value for fluorine. So, this series is known as electrochemical series. Now, got some idea about this. Let us discuss more about this. Look at this. Here, the hydrogen is placed in the middle, standard hydrogen electrode. Okay, its value is 0 SG for standard hydrogen electrode. Here, lithium is placed at the top of the series, whose value is minus 3.045, and here at the bottom lies your fluorine, whose value is plus 2.87 volt. So, that means this value goes on increasing. You have studied the number line na middle re kon rahe 0, and before that the negative value, then after 0 positive value, just like this. Negative values are placed above hydrogen, positive value are below hydrogen. Okay. Then what is oxidizing agent, what is reducing agent? First you should know, most of the students know what is oxidizing agent and what is reducing agent, but for those students who have forgotten, I want to just recall your memory, because if you do not know about oxidizing agent and reducing agent, then it will create problem to understand the electrochemical series. So, oxidizing agent, also called as oxidizer or oxidant. What is that? It helps in the oxidation of others. Oxidation is loss of electrons. So, it is such type of species which helps in the oxidation of others by gaining electrons. Se nije gain kariki anyara oxidation ne help kare. So, an oxidizing agent is a chemical species that tends to oxidize other substance by making it lose electron. It helps in the loss of electrons of other by accepting electrons. So it is an electron acceptor, it will accept the electrons which are lost by others. So it gets reduced itself, that means it undergoes reduction. So elements having the high value of standard reduction potential are good oxidizing agents. The elements whose SRP, the standard reduction potential, is high, those act as good oxidizing agents. So that means the standard reduction potential is directly proportional to the oxidizing power. Okay. Then what is reducing agent? These are the reagents which help in the reduction of others by what? By losing electron. That means they lose electrons. That means they are electron donors. So by losing electrons, they will themselves gets oxidized. So the SRP, what about the SRP? The standard reduction potential value is inversely proportional to the reducing power. Reducing power. That means if the standard reduction potential value for an electron, for an electrode or element is less, then its reducing power is more. Okay. That means the oxidizing agent that will what? That will give take electron by gaining electron. So what will happen? So by this it will itself be oxidized and help in the oxidation, the oxidizing agent itself be reduced. Okay, and it helps in the oxidation of others. Similarly, the reducing agent, it helps in the reduction of others. Okay, by this it is oxidized. So I have told, if there is an oxidation, there must be reduction. So when a species donates electrons, then there must be a species to accept its electron, isn't it? The substance oxidized by losing electrons, the substance is reduced by gaining electrons. Then again, what about the oxidizing power? What is about the reducing power? What do we obtain their value from the electrochemical series? We will obtain like this. A question may arise in your mind, ma'am, the series is so long, so many elements are there. So what to remember and how to remember? So no need to remember the values of all the elements or the name of all the elements. If you want to remember, then remember only this 20. Lithium, potassium, barium, calcium, sodium, magnesium, aluminum, zinc, then chromium, cobalt, nickel, hydrogen, copper, silver, nitrogen, bromine, oxygen, chlorine, gold and fluorine. Only remember this order. Okay, and the middle there lies your hydrogen. At the top there lies your lithium. At the bottom there lies your fluorine. So the reduction potential value, this is the increasing order of the standard reduction potential. That means at the top the elements have low standard reduction potential value. At the bottom they have high value of their standard reduction potential, and the middle there lies your hydrogen. Then what about the oxidizing power? The oxidizing power is also proportional to the standard reduction potential. So this is the oxidizing power also increases like this. That means this is the weakest oxidizing agent. The lithium is the weakest oxidizing agent, whereas the fluorine is the strongest oxidizing agent. Then considering the oxidation potential, if you consider the standard oxidation potential, it will increase from bottom to top. That means fluorine has minimum standard oxidation potential and lithium has maximum standard oxidation potential. But according to IPAC convention, the electrode potential are represented in terms of the standard reduction potential. That is why we have represented by increasing order of the standard reduction potential. But if you are asked about the standard oxidation potential, you should know it increases from bottom to top. So, what about their reducing power? The reducing power also increases from bottom to top. That means the fluorine is the weakest reducing agent among all, and the lithium is the strongest reducing agent among all. Okay. So, you should know the value of lithium, their electropotential, the standard reduction potential of lithium. It is minimum, what is that? minus 3.045 volt, and for hydrogen it is 0.0 volt. For fluorine it is plus 2.87 volt, and above your hydrogen the values are negative. These elements have negative values, and below the hydrogen these values are found to be positive. These are the, I am considering the reduction potential value, standard reduction potential value which increases in this order. So, just remember these 20 elements, the values of lithium, fluorine and hydrogen, then about the oxidizing power, reducing power, this much sufficient. So, then discuss about the characteristics of electrochemical series. So, first, as we have discussed, the elements having greater reduction potential are reduced easily. The elements which have greater reduction potential, that means suppose I am giving one example. Let us consider your zinc and your copper. The standard reduction potential values of zinc is minus 0.76 volt. We have discussed it in the first portion of this class. Minus 0.76 volt is the reduction potential of zinc, and that of the copper is plus 0.34 volt. So, whose standard reduction potential value is greater? Look at this, whose value is greater? The value of copper is greater than that of the zinc. We are considering the standard reduction potential value. So, among these two, so which will undergo reduction easily? Which will undergo? That having the element which has high value of standard reduction potential will undergo reduction easily. It has the tendency to gain electron. So, that means the copper Cu2 plus will be reduced easily in comparison to the zinc, that is written here. Okay. Then the element with low reduction potential get oxidized easily. Low reduction potential between these two, which has low reduction potential value? Zinc has low value of reduction potential. The reduction potential value of zinc is less than that of copper. So, the zinc has a tendency to lose electron, that means it has more tendency to undergo oxidation. So, it will be oxidized easily. That means zinc will produce Zn2 plus by loss of electron. Now, you are clear, greater the value of reduction potential, greater will be its tendency to gain electron, and lower is the reduction potential value, greater is the tendency to undergo oxidation. Okay. Then some more characteristics. The elements which lose electrons easily have low reduction potential. That means what? Consider your lithium. Lithium is a metal. So, by losing electron, it becomes Li plus. So, by losing one electron, it attains the electronic configuration of helium. So, it has the tendency to lose electron. So, it has no tendency to gain electron, it has tendency to get itself oxidized. So, this has the minimum value of standard reduction potential. If you see the electrochemical series, you will find that the standard reduction potential of standard reduction potential of lithium is minimum, isn't it? Standard reduction potential. So, Li plus 2 Li, it is minimum among all, minus 3.045 volt, isn't it? So, that is written here. The elements who lose electrons with great difficulty have a higher reduction potential, just like your fluorine. It has no tendency to lose its electrons. Okay, it has the tendency to what? To gain electron. By gaining electron, it will attain the configuration of nearest inert gas. So, it has no tendency to lose its electrons. So, that is why it will lose its electrons with greater difficulty, and that is why its standard reduction potential is highest. Its standard reduction potential is highest among all. 2 point positive value 87 volt. Okay, that means from this what will you understand? You will understand that it has very difficult. It don't want to lose its electrons. So, its standard reduction potential value is highest. Then some more characteristics. The elements having lower reduction potential are placed at the top. Yes, they are placed at the top. They have lower reduction potential. That means they have the tendency to undergo oxidation. They have less tendency to undergo reduction. So, just like your lithium, potassium, sodium, calcium, magnesium, aluminium, they are placed at the top and they have low value of what? They have low value of their standard reduction potential, isn't it? So, then next is your then the elements which are placed below at or bottom, they have higher reduction potential values. The higher reduction potential value, just like your fluorine, chlorine, copper, silver, they are placed at the bottom of the series because they have high value of their reduction potential, and standard hydrogen electrode is present in the middle of the series. So, the elements are arranged like this. The oxidizing power that increases as we move down in the electrochemical series. Already we have discussed about the oxidizing power. It is directly proportional to what? The oxidizing power is directly proportional to the standard reduction potential. So, greater is the standard reduction potential value. Standard reduction potential value, greater will be the oxidizing power, and reducing power increases as we move up, just the reverse. So, as we move up, the reducing power increase. Okay. So, then if a non-metal is a strong oxidizing agent, then its corresponding ion is weak reducing agent. Okay. So, if a metal is a strong reducing agent, then its corresponding cation is weak oxidizing agent. We will discuss it. If a non-metal, non-metals are your fluorine, chlorine, bromine, iodine, these are the non-metals. If a non-metal is a strong oxidizing agent, just like your fluorine, fluorine, chlorine, bromine, iodine, fluorine, then comes your chlorine, bromine, iodine. So, if you arrange these non-metals in the decreasing order of their standard reduction potential values, the fluorine has the maximum value of its standard reduction potential. That is why. So, fluorine is the strongest oxidizing agent. So, if we are arranging the non-metals in the decreasing order of their oxidizing power, then their corresponding ion F minus, here Cl minus, Br minus, I minus, their corresponding ion follow the reverse order. Okay, then its corresponding anion is weak reducing agent. This is the strong oxidizing agent, this is the weak reducing agent. Okay, now you understood about this point. Then come to this. If metal is a strong reducing agent, if a metal is a strong reducing agent, then what happens to its corresponding ion? Sodium, potassium, magnesium, aluminium. If the reducing power of a metal is more, then that of the corresponding ion will follow the reverse order. Okay, that is written in this point. So let us go to the next portion about the reactivity. Reactivity of metals decreases down the group. It will decrease down the group. Suppose lithium, potassium, magnesium, aluminium. So these are the metals. So this is the lithium which is placed at the top of the series. So the reactivity, consider the reactivity, it will decrease like this. Because the reactivity of a metal depends upon what? Its tendency to lose electron. जो metal जिते शीघ्र इलेक्ट्रॉन लॉस करिवो तार reactivity सेते अधिक. So which will lose electrons easily? Among this, lithium has the tendency to lose electron easily. That's why the reactivity will decrease when you move down the series. Because if you move like this, their tendency to undergo reduction will increase and the tendency to undergo oxidation will decrease. That's why the reactivity will decrease, because the reactivity of a metal depends upon its tendency to undergo oxidation. That's why it will decrease like this. Then about the non-metals, the reactivity of non-metals depends upon the what? It depends upon the tendency to gain electron. जेते शीघ्र गोटे नॉन मेटल जेते इलेक्ट्रॉन गेन करिवो से ता ऊपर तार रिएक्टिविटी डिपेंड करे. सो इट विल इंक्रीज डाउन द ग्रुप. दैट मीन्स आयोडीन, ब्रोमीन, chlorine, fluorine. These are the non-metals. If you consider the reactivity, then the reactivity of this non-metal will increase in this order down the. If you see the electrochemical series, then you will find iodine first, then comes the bromine, then comes the chlorine, and fluorine is placed at the bottom of the series. That means for reactivity, what will happen? So here the reduction potential value goes on increasing. That means the tendency to undergo reduction increases, and we know the reactivity of non-metals depends upon their tendency to undergo reduction or gain electron. That's why the reactivity will follow this order. Okay. Then the applications. The applications of electrochemical series. Why we need to study the electrochemical series? ताको पढ़िया हमर कौन दरकार? It is used to calculate the standard EMF of a cell. Let us calculate how the standard EMF of a cell is calculated. Let us do it. Standard EMF of the cell, E naught cell. How it is calculated? It is calculated by the formula. The formula ta kona? We have solved certain problems using this formula. So tell me the formula. It is the standard reduction potential value of the right hand electrode or cathode minus the standard reduction potential value of the left hand electrode, the anode. Okay. If you know the reduction potential value of cathode and anode, then we can calculate the E naught cell. Suppose the standard reduction potential value, the standard reduction potential of zinc electrode is given, Zn2 plus Zn is given, it is minus 0.76 volt, and the standard reduction potential of the copper electrode is been, that is plus 0.34 volt, and you have to calculate the E0 cell, the standard cell potential. So how to determine, केमते जानिबो which is anode, which is cathode, केमते जानिबो, already हमें Daniell cell रे पढ़े, zinc will act as anode, copper will act as cathode, but how to know if some unknown electrodes are given, केमते जानिबो, remember the electrode having high value of its standard reduction potential will act as cathode or the right hand electrode. जहार standard electrode potential value higher थिबो ताको cathode बने देबो, just like your copper. So here the copper will act as what? The right hand electrode or cathode, and the electrode which has low value of standard reduction potential will act as anode. Low value of standard reduction potential means it has tendency to lose electron. That means it has the tendency to undergo oxidation. That's why its standard reduction potential value is less. So it will, your zinc electrode will act as anode. So then put the values. So right hand electrode jagare kon basebo, kahar value basebo na that of copper, and left hand electrode kahar value basebo minus 0.76 that of zinc. So you will obtain 1.10 volt. Okay. So like this you can calculate the standard cell potential or standard EMF of any cell. So next, what do you? Relative oxidizing and reducing capacity. You will be able to find out the oxidizing power, the reducing power of any electrode by using this electrochemical series, because you know greater the reduction potential value, more easily is the substance is reduced and stronger will be the oxidizing agent. Okay. So similarly, lower the reduction potential value, more easily is the substance gets oxidized and stronger will be the reducing agent. So that means the lithium and fluorine. If you compare these two, then which will act as strong oxidizing agent? The lithium which has low value of standard reduction potential, then it will be the weak oxidizing agent, and this has the high value of standard reduction potential. So that's why it will act as strong oxidizing agent. This is the strong oxidizing agent, this is the weak oxidizing agent, and the reverse order is followed for the reducing power. Okay. Then for predicting the feasibility of a redox reaction, we have discussed the feasibility of a reaction, how to determine whether the reaction is feasible or not. It is determined from the value or the sign of the standard free energy. If its sign is negative, then that reaction will be feasible, otherwise not. So what is the relationship between standard free energy and EMF of the cell? The relation is just like this. Delta G0 is equal to minus F E0 cell. That means if the E0 cell, the standard cell potential is positive, then only the gives free energy will become negative, and then only the reaction will be spontaneous, means it is feasible, otherwise it will be not feasible. Okay. Suppose consider your same Daniell cell. Suppose the reaction Cu plus Zn2 plus gives rise to Cu2 plus Zn. Whether this reaction is feasible or not, you are asked whether this reaction is feasible or not. So here in this reaction, which will act as cathode, which will act as anode, looking at this reaction will predict the copper is undergoing what? Oxidation. That means it is the anode, copper is the anode, and the zinc is undergoing reduction. That means it will act as cathode. Now you know which is cathode, which is anode. You know the value. You know the value of their electrode potential. So put the value E naught cell, calculate E naught cell, that is E naught, the reduction potential of what? Here what will be your cathode? Here zinc is your cathode. So put its value Zn2 plus zinc minus Cu2 plus Cu. So its value, you know, its value is minus 0.76 volt, minus that of copper is minus 0.34 volt. So you will obtain minus 1.10 volt. The E naught cell is obtained to be minus 1.10 volt. So what about the delta 0? What will be its sign? So it will be minus NFE. N is the number of electrons, that is 2. F for Faraday 96500 into F, eta kete paila? Minus 1.10 volt. So you will obtain value whose sign is positive, isn't it? So delta G naught will be found to be positive. So if delta G0 is positive, then the reaction will be not feasible. This reaction is not feasible. This is a non-spontaneous reaction. So from the sign of the E naught cell, you can predict whether the reaction is feasible or not. That means the copper will never undergo oxidation and zinc will never undergo reduction. If you combine zinc half cell with copper, then copper will undergo reduction and zinc will undergo oxidation. जेकोनस reaction लेखि देकी तमे कहि परिबन कि this reaction is possible. You can only predict the feasibility by looking at the sign of delta G naught. If it is negative, then only that reaction is feasible, otherwise not. So using the electrochemical series, you can predict the feasibility of any reaction. Come to the next application. Predicting capability of metals to displace hydrogen gas from acid. So just like your, suppose zinc, suppose when zinc reacts with sulfuric acid, what will happen? The zinc sulfate will be produced with the evolution of hydrogen gas. That means the zinc displaces hydrogen from the acid. This is the acid. It displaces kagu na hydrogen ku. So remember, only those electrodes which are placed above the hydrogen, तो SHE रहला middle रे standard hydrogen electrode, ता ऊपर elements गुड़ा को रहिले metals which are placed above the SHE, they will displace H2 from the acid. Just like your zinc ho, sodium ho, potassium ho, magnesium ho, aluminium ho, those are able to displace H2 from acid because their standard reduction potential value is lower than that of the acid. That means they have the tendency to lose electrons. That's why they only will displace H2 from its acids. Okay. Then displacement of metals. So there are certain metals, they will displace some other metals. The metals which are placed above will displace the metals which are placed below in the electrochemical series. Just like your the zinc will displace copper from its solution, producing zinc sulfate. Okay, here zinc displaces copper, producing ZnSO4, but copper cannot displace zinc because it is placed below the zinc. So the elements which placed above, they will displace the elements which are placed below. Then some questions regarding the electrochemical series. The questions may come like this: when a copper strip is placed in aqueous solution of AgNO3, the solution becomes blue. Why? Why the solution becomes blue? The answer lies in this. So what will happen? copper strip is placed in aqueous solution of AgNO3. If you see the electrochemical series, first comes your copper, then comes your silver. So what will happen? The copper will displace the silver. That means if you place copper in AgN3, what will happen? You will obtain the reaction like this, plus 2Ag. So the copper will displace the silver from its solution. So the solution becomes blue due to what? Due to production of Cu2 plus ion. Due to Cu2 plus ion, the solution will become blue. Okay, the questions may come like this. Then the solution of copper sulphate is blue. On placing a zinc strip in it, the solution becomes colorless. Why? You know the color of the zinc sulphate, the color of copper sulphate is what? The color of copper sulphate is blue due to the presence of Cu2 plus ion, which is blue in color. But on placing zinc strip in it, so what will happen? When zinc is placed in it, ZnSO4 is produced plus Cu. So there is no Cu2 plus ion. That's why the solution will become colorless. But if a strip of silver or gold is placed, suppose in place of zinc you place silver, then what will happen? The silver cannot displace or substitute copper because it is placed below the copper, so it cannot displace. So that's why what happens? Solution contains the Cu2 plus ion, due to which it is blue. Okay. And the last question, why nickel cannot displace magnesium from MgSO4? MgSO4 को काहेंकि displace कर परियो नहीं? Because if you see the electrochemical series, then you will find that the magnesium is placed above nickel. So nickel cannot displace magnesium, whereas magnesium may displace nickel. So this is the reason. So this is all about your electrochemical series. So next class we will discuss about North's equation. Thank you so much.